going to calculate the arc length on Mathematica or in my calculator, I am going to do the following. I'm going to, by hand, start to set it up, okay? So R prime gives you the derivative vector, so it gives you the tangent vector, not the unit tangent vector, but the tangent vector. So for my function here, I have a product, so first times the derivative of the second plus the second times the derivative of the first times derivative of the second plus the second times derivative of the first, and then the derivative of t squared is 2t. And then here I have 2t and then 50. Okay, so that's my tangent vector, not the unit tangent, because I didn't make it have length 1, but this vector is tangent to the curve at any point. So you plug in a t, you get a vector that's tangent to your curve. The arc length is the integral of the length of the tangent vector evaluated from the beginning and ending point that you're interested in. So we're interested in starting at 0 and ending at 30, and I need to square all these terms, and it's going to be kind of messy, so I think for starters I will just type 200. The 2 times the 100 is where I got 200. T cosine of 2t plus 100 sine of 2t plus 2t literally take the x in R prime and I squared it. I took the y in R prime and I squared it. I took the z in R prime and I squared it. And so, like you guys, I'm sorry, I wrote the square root knowing we needed to take the square root, but I should have written, I guess I should have written that. The length of R prime is what I've written down. Okay, so we integrate the length of R prime. So again, what you're doing is you're taking infinitesimal of these little tangent. The tangent vectors are following the curve. And so as they follow the curve, and you break them up into little tiny segments and add them all up, you're going to get the length of the curve. And so integrating is adding up infinitesimally small pieces. The pieces we're adding are lengths of the tangent vectors. And so what's written down here is how you find the length of the tangent vector. So the length of any vector is the square root of, a squared plus b squared plus c squared, and that's what we have there. Now, if I try to clean this up further, it will clean up a bit, but it's certainly not going to give us something that's a nice integral to work out. So I'm not going to try to work out the integral. Instead, we're going to use the calculator or Mathematica to finish working it out. Josh, are you just...
Fist pumping.
Okay. All right, so let's use our calculator, and I will go into Mathematica and kind of show you the same thing in Mathematica. Again, at the moment I'm waiting for the computer to boot up.
Hey, so Ms. Mosier, I was looking through the notes and there's a theorem or whatever that has the integral of just the R curve, not the derivative. Why would that be used?
Well, let me see what you're looking at, so that I make